Hey everyone, it's time to start Chapter 9. The motivation for Chapter 9 is to find some statistical ways to see if two variables are related in any way. So one way to do that is to talk about correlation. Correlation is another word for relationship. And we could look at a graph, and a good graph to decide these things is what's called a scatter plot, and that's what I have projected here. A scatter plot has two variables, one on the x-axis and one on the y-axis. So here we have husband's age as one variable and wife's age as the other. Typically the x variable, which is on the horizontal axis, is called the explanatory variable, and the y-axis is the response. Okay. So if we look at the dots, so scatter plot is just an array of dots. Each dot here has two variables associated with it. For example, say this dot right here looks like the husband's age is 54, 55, and the wife's age maybe about 44, okay? And if we look at the overall pattern of the dots, that's what we're after. Is there any pattern? And if there's a pattern, then there's a relationship between the two variables. This one, the dots are trending upwards. That would be a positive correlation if we see dots trending upwards, which makes sense. As the husband's age increases, so does the wife's age. Okay. Now there's going to be some that are not quite in the pattern, like maybe something like this one, right? Or things that are just away from the main pattern, but that's generally what we're looking at. Then we're going to talk about, how strong is the pattern? How linear are these dots? Do they make a straight line? That kind of thing. Okay. Really, we're just after linear correlation for this section, so we're only worried about if the pattern is a line. So if I look at another graph, we'll pretty much have three different types of things happening. We have this one that we just saw where the dots are going upward. That's a positive linear correlation. This one where the dots are trending downwards, that's a negative linear correlation. Or this one where there's just kind of no pattern, that would be no or little correlation. Okay, so we have positive, negative, and none. And then the closer those dots are to a line, the stronger the pattern or the stronger the correlation. Okay, so let's take a look at the notes packet, and we'll start to go through some examples of this. So let's go to that. I've already talked about the nuts and bolts of this. So here we have some different examples. So what kinds of relationships might you think these are, right? So we have stat score versus college GPA. Well, yeah, it seems like if the stat scores increase, then so does the college GPA typically, right? So that would probably be something like this one, the positive linear correlation, right? Where here where we'd have SAT scores, did I say stat scores? SAT scores, and then versus GPA, right? It's a little thick. Let's maybe dial that down a little bit. Okay, how about height versus IQ? Well, there's really no patterns there, right? Your height is not gonna define what your intelligence quotient is. So that one would probably look more like this one down here, height IQ. It would be really hard to predict someone's IQ based on their height. Okay. The next one is number of absences and the test score. Okay, that seems like as the number of absences increases, the test score would decrease. So that would be an example of a negative linear correlation. Okay, that makes sense, like this one right here. A lot of absences, low test score. All right. Now we're looking at general patterns. Of course, there's going to be scores like this, maybe, right? Not very many absences, but still a low score, or maybe something like that up here. right? Where you have a lot of absences, but the student still does well on the test. Okay, so that's a general overview. Let's get to some that have some numbers in it here. Here are the ages of 10 men with their systolic blood pressure given below. Is there any pattern in this data? One way is to come up with a scatter plot, and StatCrunch can make a scatter plot if you have the raw data loaded in there. So that data is in your groups folder if you want to access it. I'm gonna go ahead and take a look at and load this data into StatCrunch. It's gonna be a lot easier to see any patterns if we have a graph. Good. So let's take a look at StatCrunch. Okay, so here's the data loaded into StatCrunch. For this entire section, you're going to be doing one StatCrunch technique, really. And I'll show you what that is right now. Okay, it's what's called regression. Okay, and we're only worried about simple linear. That's going to get most of your answers in this section if you can just do the stat, regression, simple linear. Just make sure your X variable, your explanatory variable, and your Y variable are correct. You don't have to really worry about any of this right now. We'll get to some of that later, and then we're just going to compute. Okay, gives you a lot of information. We're going to get through all of this later, but notice there's some arrows here, right? If I click over, it's going to give me the graph. Okay, so it gives me the 10 men, and notice there are 2 variables for each dot, right? And now I can see if there's any pattern. Don't worry about that red line for now. Okay, we'll do that later. But I can definitely see that the dots are trending upwards. As age increases, blood pressure tends to increase. So I would say that this is a positive linear correlation. So that would be my pattern. And I'm just writing that in my packet. Positive linear correlation. Okay. The next question is, how strong is that pattern, right? Like, how well do they fit on a straight line? Like if all of those dots were right on that red line, that would be a super strong linear correlation. And then as you get more spread away from that line, the correlation gets weaker. There's a numerical value that describes the strength of a correlation. The formula is in your packet. You can see there, it's like insane. We're not going to do it by hand. Feel free, I guess, if you're adventurous, but honestly, just use StatCrunch to get that value. It's called a correlation coefficient, and it's going to measure the strength and the direction of a linear relationship between 2 variables. Okay, that is also in this printout. If I go back to that page, you'll see the R, correlation coefficient. Okay, so this one, the R is 0.9083. Let's talk a little bit more about that coefficient and the range of it and how to tell what it gives you. Right? What does this 0.9 mean? If I jump back to my packet real quick. The R value, the range, is always between 0 and 1. So it's, wait, that's not right. -1 to 1. Sorry. Back up. The range of R is -1 to +1. Okay? And so then if X and Y have a strong positive linear correlation, then R is going to be close to 1. If X and Y have a strong negative linear correlation, then R is going to be close to -1. And if there's really no or a weak correlation, then R is going to be somewhere in that middle range close to 0. So I notice here that R being 0.9 for this problem that would be a strong positive linear correlation. Okay, closer to R to 1, stronger it is. All right, so use StatCrunch to find, yeah, so now we can say, yeah, we are, okay, write it again, 0.9083. And I would say that's a strong positive linear correlation. Okay. So if the dots were trending downward, you're going to see that R is negative, right? But it still could be strong, right? Still like negative 0.9, just the dots would be trending down, but really tight, close to a line, okay? So it's weak if it's closer to 0, like a 0.1 or something like that. That would be that array of dots with no real pattern. Okay, now if you want to practice a little bit about what this R is telling you, or what a R value compares to a graph, whatever I'm trying to say, go to this applets in StatCrunch. And there's this thing called correlation by eye. If I click on that, I can just randomly generate some data. And then it's just going to give me a scatter plot. And then I can either I can guess what that correlation coefficient is, or I can just show it. And that way I can start to see, okay, what does an R value look like compared to its graph, right? So now I'll just show this one. There's a 0.3, right? And then I can reset. And then I could put whatever sample size I want, and then just hit enter. And then I can look at that one. That one looks like a pretty strong negative correlation there. And I can just click show. I don't really feel like guessing. That's negative 0.95. Yeah, super strong. If I want to do another one, I could just click on that box and hit enter. And I can just, to keep hitting enter until I see one that I want to look at. Right, change that sample size. Okay, and then this is just an exploration thing. Get a better feel for what a R value looks like compared to its graph. Okay, I'm going to stop there for now. It's a good stopping point, and then I'll restart a new video starting with page 3 in the handout. Okay, hope all is well. Talk to you later.